Hello Linux users. In this video we will discuss some aspects of the Unix based file system hierarchy, as well as some terminology like relative and absolute paths. Now in most file systems we can view the file system as an upside down tree with the root at the top, where you cannot go any further up from there, and then with branches and leaves spawning from the root, cascading down. Now obviously branches can have further branches, and usually branches stop at leaves, so you can visualize like branches, like the nodes of branches are actually directories, and the leaves are just files, where you since you cannot have in a file system, usually a directory can contain subdirectories and files, but a file cannot contain any further directories. Usually the branch terminates at the file. So let's have a look at the system, a Linux system. If we just from here, I mean, usually when we open up a terminal in our Linux in a Linux environment, by default we are located inside our what's called the home, the user home. If we just do a pwd to print our working directory on the screen, that home happens to be under /home/stam. In fact, my home right now is not the home, is just a name for the directory containing all the user homes, but my actual home is the whole path with base name, the stam, and dir name. If you do the commands, basically will show you this. The dir is /home. I mean, just quickly to show you what I mean is, if you do a dir name on pwd, that's like this dollar parenthesis and the command inside. What it does is the same as putting backticks on it. Those is as if you include the pwd in those kind of quotes. So you will execute the pwd and take that, whatever the pwd produces, which will be this, it will take that as an argument for dir name, and dir name basically displays all the directories on a path up to the last point, which is obviously called the base name of the path. So if we do this, yeah, and if we do basically a base name on the pwd, it should give us the stam, yeah, and it does. Okay, so from this point, the information that pwd gave us back is this one here, and that actually has a bit of a peculiarity. Just bear with me for a second. Now this is basically a path, and it consists of 2 slashes and 2 directory names. Now strange though it might sound, the first slash and the second and the other slash are actually completely different things. They do not signify the same thing. They might be using the same symbol, as this is a case of let's call it symbol overloading, same kind of analogous to a situation where you have in development, in programming, you have operator overloading, where, for instance, let's consider that you have 2 numbers, 2 integers or decimals, doesn't matter, and you put the plus in between them. Then the language knows, and it means that you want to actually add them, so he adds them up and does whatever it does with the result. But if you take 2 strings, I mean, in real life we don't actually do that. but if you take two strings and put the plus in between them, most of the languages know what you want to do, and what they will actually do is concatenate those strings and produce a result. Like if one string is ABC and the other is DEF, then the resulting string will be ABCDEF, something like that. This is called operator overloading. This is not like some auto magic thing or anything like that. This is the language itself has been, the compiler or interpreter has been written in such a way that it can distinguish between context of arguments and act accordingly. Well, this is the same situation here. Here, the slash at the very front of the path, it actually means the highest point in our directory hierarchy, the root basically. And this one here, the slash in between those two directory names, it just basically acts as a separator between a directory, stem, and its parent directory, home. That's all it is. So although it is the same symbol, it has completely different meanings in those two occurrences here in the same path name. Now, when we're actually specifying a path by using a slash in front of the that path, if the path starts with a slash, then we call this path an absolute path name, because it is always, whatever follows that slash will be considered from the system to be in relevance with a slash of the file system. So although it's still a relative path name because it's relative to the slash, but because the slash is a special point in the structure to be, then we can consider all the path names that start with a slash to be absolute path names. That's how the system interprets them. If any path starts with any other character, anything else is not an absolute, is actually a relative path name. For instance, in what we ran earlier, here you see that the dir name of the output of this command gives me an absolute path name, which is /home, meaning that well, relative to the slash, the directory that contains this the current working directory is /home, and the base name actually gives me a relative path because it doesn't start with a slash, it starts with the name s. Therefore, it actually means that from whatever directory this is working from, the current directory contains a stam child in there, either file or directory. Now, this only happens because these commands handle this output in a special way. Forget about that for the time being. Let's do some navigation. Let's say that I'm actually in my home right now, right? And I want to go to the root directory, like the slash, but not without specifying the slash. Okay, how can I do this? Well, there's two ways. There's actually a few ways of doing this. What we can do is we can go a directory app, and then another directory app, and here we are. Or let's go back with a CD back to the home. We can specify a directory app, then use a slash, which in this case again is actually just a separator, separates between this directory and its parent. Okay, and basically what we say here, we say go up a directory and then another directory, go up another directory. So knowing that slash is two directories from us, we just supply this, and here we are back to the slash. How else could we do? We could have done a bit of a fancy thing, just to show the how the current directory is actually denoted by a single dot, and how the parent directory of the one that we're referring, or we are using or referring, is denoted by a double dot. So for instance, if I do here I am actually at the house, at the home, sorry, house. If I type cd dot, that means change into the current working directory. I mean, it's pointless, but it will just leave me where I am. It's not gonna move me or anything like that. It shouldn't, because the dot means this current directory. But what I could do is specify, go back to the slash using a bit of a more complex way. I mean, it's no point doing it, it's just to show the concept. So we can go cd, change directory, from the slash, from the current directory, go separator, go back one directory, separator, go back another directory, separator, then change into the current directory. This would actually just take you back to slash and leave you there. Let's see, yeah. Now the reason for this doing so is because, well, those have actually no effect. If we are just asking the program to change into the current working directory, then it's not going to do anything. It's not going to move us away or anything like that. Now this way of specifying path names, but in relevance to where we are, is called actually the relative. They are called relative path names. If we are in a specific directory, I mean, right now we are actually under the slash, and there is actually a bin directory in there. If I want to list it, there are two ways of, or actually more than two ways of doing it. One way is to just say ls/bin, but that will actually call it in an absolute path, which we don't want. Well, for any reason. I mean, it's not that we shouldn't use it. I mean, I'm just saying we want a relative way of calling it. The best way is to just either do ./bin, that will list it, or even better, since we are actually in the same directory as the bin, we can just say ls/bin, and the system knows. I mean, it's changed the output. I'm just gonna redemonstrate so you know. It's just that it changes, it refreshes quite faster than the camera can pick up, and so it appears as if it's not moving. Okay, so basically the ways to move, to navigate through your system using absolute paths, you always have to include the slash in front of every path, and obviously the path has to make sense relative to that slash. So altogether it's called an absolute path. The relative path is a path which makes sense from the point where you are on the system, not from the absolute top end of the file system. For instance, from here, if I want to go into my desktop directory, which is under my home, this is, I can go using relative paths by saying cd home. That should actually take me into home. Then cd stam, and I can actually be fancy, do a bit of, well, not trick, but can be a bit fancy and just say stam/desktop, and that should take me in, because the desktop here with this is a separator again. It was the desktop reference was in conjunction with the parent directory, which was stam of this directory desktop, and here we are. Basically, if I just print working directory here, it just shows me inside my desktop. But this is basically the basic operation of navigating through the shell. It all boils down to just basically using the appropriate notation for the appropriate situation. Sometimes you have to make sure that you use absolute path names for one reason or the other. Some other times it's more easy to use relative path names. It just boils down to what you actually need to do on the system. And that's basically, that concludes this video. I hope this was explanatory and instructive to you. Thanks for watching. I will be seeing you soon in in my later future videos. Take care of yourselves for now. Goodbye.